Problem 80, remove duplicates from sorted array 2. This is the second version of a problem where we have, as in previous problem, we have an array nums containing integers sorted in a non-descending order, something like this. And it may contain duplicates, obviously. So we have to remove all duplicates which occur more than twice. So 2 occurrences is fine, but every third occurrence should be removed like this. So in the final array, we'll have 1, 5, and 5, which is fine because these are only 2 occurrences. 7 will be kept. 8 and 8 will be kept, but this 8 will not be kept. So 9 and 9 will be copied over. Does not matter what garbage is left over after this point. We just have to remove, we just have to return the number of meaningful elements so that we signal where the truncation should occur and where the garbage starts. In order to do this, we will follow the following simple algorithm. We will have 2 pointers. One will be called length, and this will be the length of the array which we have correctly filled already. So I'm going to assume that length is 0 initially, so nothing we have filled in correctly initially. So this is the part of array. Array starts here, but we have correctly filled nothing at the beginning. That's how I'm going to assume. And I will have a second pointer called I. I will go through all of these elements and will consider them to be a candidate to be added into the accepted elements, right? So if at some point I is pointing to this element, and let's say length is pointing to one of those elements, let's say here, yeah, that means this element is considered still empty, and it needs to be, this isn't actually probably a great example, but anyway, so this element is considered to be empty, and it will be filled next. So we have to compare this 8 here to this element and this element. If it's different from even one of those, then this element is fine. This means at most it can be equal to this one. So we can copy it over here and instantly increment length to point to the next element. I think we can implement this. Right. So to do that, as we said, we're going to have let length equal 0. For let I equals 0, I is less than num's length plus I. Now, if some condition happens, then we should take num's length plus. So basically, we're going to copy num's I into num's length and then increment length afterwards. Now here, basically, we have to write something like num's I should be different from num's I is not equal to num's length minus 1, or num's I doesn't equal to num's length minus 2. Now, for JavaScript, for TypeScript, this should be fine, because even if sometimes we fall out of the range of the array, so length minus 1 could be negative, length minus 2 could be negative, JavaScript will return undefined. There will be no memory violation. We will just get an undefined, and this comparison will return true, because an integer can never be equal to an undefined, so this will be true. And this will also be true if we fall off the cliff, fall off the range of the array. But I mean, we have to still properly write this. So what we have to do here, if length is, it's either less than 0, less than 1, or this inequality happens. Oh, sorry, this is quite dumb. If it is less than 2, then we will always copy these elements, right? If it's less than 2, we will always copy these elements. Yeah, that makes sense. So if length is less than 2, then we definitely need to copy that element, because the first two elements, if they exist, will always be required. Now, why don't we start length with 2? The reason here is that there may not be 2 elements in the array. Now, we are assured that there will be at least 1 element in the array, but we can, instead of starting from 1, why don't we then just make it 0, and this function will then be able to process even empty arrays. This way we should be able to process even empty arrays. So we're going to say if length is less than 2, then we're going to, this will always return true. Otherwise, if it's not less than true, then we will compare num_i to 2 previous elements, which will always exist. And if it's different from at least one of them, we're going to still make, let's write it like this, yeah. Okay, I think this should work now. Let me try this. Let's run it on the pretests. A function who, all right, we have to return length. That's the beauty of TypeScript. That error would not be caught in JavaScript. Okay, these things passed. So let's submit this now. And let's see what happens. Okay, 60 milliseconds, not great. Okay, this is not really fantastic results, but it still passed. Let's try to improve timing a little bit. So let's start from 1, because we know that there is at least 1 element in the array. Now, we could also start I from 2, right? We would look at the, no, we should look at the second element, which is I equals 1. Yes, and now this could also maybe optimized. Less than 2 will mean it's equal to 1. So we could potentially do it like this. Let's try it on the simple tests. And now submit. Let's see if we can improve this slightly. Not exactly. I think we made it actually quite worse, right? Okay, I mean, what could be responsible for this? It's hard to know. I mean, this solution is decent. Time complexity is exactly what we need. This is O, the length of a num. So O n, whatever the length of this num is, big O of that. So that's the time complexity.